Ever, click something on your computer, type something in, loaded a file, and just watched it do
Oh,
something?
yeah, that whole interaction thing.
Exactly. Where you give it information and it gives you something back. That's like the core of almost all software, isn't it?
Absolutely. It's fundamental.
So today, we're going to really get into how C++, the programming language, deals with that whole give and take, input and output, IOO.
Right. And for this, we've been looking at some great explanations from Professor Jerry C. Soy over on his YouTube channel, specifically his videos C++ Input Output Part 1 and Part 2. They really break it down clearly.
Yeah, they do. So think of this as kind of a quick way to grab the essentials of how C++ talks to the outside world.
Whether you're, coding right now, just starting out, or maybe just curious about how software actually works under the hood.
We're basically pulling out the key ideas, the aha moments, you could say.
So what's on the map today? We'll cover the main library IOStream, how C++ reads and writes different kinds of data.
How it handles tricky things like spaces.
Yeah, white space. And using special functions for more control, what happens when things go wrong with input?
Oh, error handling, right.
And making your output look neat, dealing with text that has spaces, and then finally, how to do all this with files too.
Cool. Let's dive in. Why is I/O even necessary in the first place? Seems obvious, but maybe worth stating.
Well, yeah, it kind of is obvious when you think about it. A program needs stuff to work on, right? Data.
Information, yeah. Numbers, text, whatever.
It takes that stuff in, does its calculations or processing or whatever its job is, and then it needs to show you the result. Otherwise, what's the point?
Right, it'd just be spinning its wheels in silence. Useless.
Exactly. So input gets data in, output gets results out. Simple as that, fundamentally. And in C++ C, the main tool for this is the IOStream library.
Okay, IOStream. And we get access to that with that hashtag include IOStream line at the top of the code.
Precisely. That's a message to the compiler basically saying, hey, we're going to need the input-output tools. Please load them up.
Gotcha. Like grabbing your screwdriver set before you start assembling furniture.
Kinda, yeah. And inside this IOStream toolbox, there are two main, well, technically they're classes, but think of them as blueprints. IsStream for input.
And for input, makes sense.
And AuStream for output. .o for output.
Okay, blueprints for data streams. And you mentioned we get some ready-made tools.
We do. IOStream automatically gives us syn and count. Syn common input is usually hooked up to your keyboard. That's how you type stuff into the program.
Okay, syn is keyboard input.
And count common output, that's typically your screen. It's how the program shows stuff back to you.
Right, and the key thing is you said we don't need to set these up ourselves. They're just there.
They're just there, pre-declared, ready to use as soon as you include IOStream. Super convenient.
Okay, so we have syn for input, count for output. How do we actually use them to, move the data?
That's where the operators come in. For input with them in, we use the extraction operator, which looks like two greater than signs.
Okay, extraction. Like extracting info from the input stream.
Exactly. The syntax is basically syn variable. So syn on the left, the operator, and then the variable you want to store the input in on the right.
And that variable could be, what, an integer, a decimal number?
Yep, an int, a double, a char for a single character, things like that. You declare the variable first, then use syn to fill it with whatever the user types.
Now, here's something interesting from the videos. How syn deals with spaces. It doesn't just read everything verbatim, does it?
No, and that's usually a good thing. By default, syn with the operator skips over any leading white space.
White space being spaces, tabs, hitting enter.
All that stuff. If you hit space a few times before typing a number, syn just ignores those spaces and waits for the actual number.
Okay. And what if you type multiple things separated by spaces, like 3 numbers?
It handles that too. If you write, say, syn num1, num2, num3, and the user types 10, 20, 30, then enter.
It puts 10 in num1, 20 in num2, and 30 in num3.
Bingo. It reads the first number, stops at the space, reads the second, stops at the space, reads the third. It breaks it up nicely.
Let's use that Harry's grades example. We set up some double variables like HP1, HP2, HP3.
Right, for scores. Doubles because grades might have decimals.
Then we'd use count to ask the user for the grades, maybe like enter 3 grades.
Yep, a prompt message.
And then one line, syn HP1, HP2, HP3.
Exactly. And if you type, say, 75.5, 80, 92.3, and hit enter.
75.5 goes into HP1, 80 into HP2, and 92.3 into HP3.
Just like that. Then you could calculate the average and use count again to display it.
Okay, so syn is pretty smart about parsing space-separated input. That handles a lot of cases. But what if we need, like, finer control?
Ah, yeah. Sometimes the default skipping of white space isn't what you want, or you need to read things differently. That's when we use functions that are part of sin. We call them using the dot notation, like sin.sum
Dot
function.
notate, okay. And one function mentioned was sin.get. How's that different?
Sin.get, specifically the version that reads a single character, is different because it reads the very next character in the input stream. It does not skip white space.
Oh, so if the next thing waiting is a space, sin.get reads the space.
Yes. If it's a new line character from hitting enter, it reads the new line. Whatever is next, it grabs it.
That seems useful if you need to process everything the user types, including the spaces or enters.
Exactly. It gives you that lower level character by character access when you get it.
Okay, then there was another one. Sin.ignore. Sounds like it. Throws stuff away.
It does. Sin.ignore is used to discard characters from the input stream. You usually tell it two things: a maximum number of characters to ignore, let's say n, and a delimiter character.
A delimiter, like a character that tells it when to stop ignoring.
Right. Very often that delimiter is the new line character, n, which is what gets put in the stream when you press enter. So sin.ignore 100, n would mean ignore up to 100 characters, or stop ignoring as soon as you find a new line, whichever comes first.
I see. So you could use that to say, clear out the rest of an input line after you've read what you need, or maybe skip over some unwanted input.
Precisely. Like in the example, maybe after reading the first two grades, you want to ignore the rest of the line, including the third grade, and the enter key press .sin.ignore is the tool for that.
Okay, this is getting interesting now. What happens if things go wrong? Like the program expects a number, but I type hello.
Ah, the dreaded input mismatch. That causes sin to enter what's called a failed state.
A failed state. That sounds bad.
It is, because once sin is in a failed state, any further attempts to read using sin will just fail silently. They get ignored.
Silently. So the program doesn't crash, it just starts behaving weirdly because it's not getting the input it expects?
Exactly. Your variables won't get updated, calculations might use old or garbage values, and you might not get any obvious error message. It just stops working correctly.
Yikes. Okay, so how do we fix that? We can't just leave sin broken.
Nope. You need to actively recover. There are two steps. First, you use sin.clear.
Clear. That clear the input.
Not quite. It clears the error flags on sin. It basically resets sin's internal state from failed back to good, making it usable again.
Okay, so clear resets the state. But the bad input, like hello, is still sitting there waiting to be read.
Exactly. That's the crucial second step. After calling sin.clear, you must remove the problematic input from the stream.
Yeah.
And how do we remove input?
With sin.ignore.
You got it. So the standard recovery pattern is check if sin failed. If it did, call sin.clear to reset the state, and then call sin.ignore, usually ignoring up to the next new line to discard the bad input that caused the failure.
Check, clear, ignore. Got it. That seems really important for writing robust programs that don't just fall over when the user makes a typo.
It's absolutely essential for real-world applications. You have to anticipate bad input.
Okay, so we've covered getting input, handling variations, and dealing with errors. Let's switch to the output side, count. How can we make the output look, well, nicer? Not just a jumble of numbers.
Right, formatting. For that, we need another library. IOManip stands for Input-Output Manipulators.
Okay, so hashtag include IOManip at the top as well.
Yep. This gives you access to special commands called manipulators that you insert directly into your count statement using the operator, just like the data itself. They modify how subsequent data is displayed.
Cool. What are some common manipulators? Fixed was one?
Fixed is a key one, yeah. When you insert fixed into count, it tells C++ to display floating point numbers, like doubles, in fixed point notation.
Fixed point, meaning like always showing a certain number of decimal places.
By default, yes. Often it defaults to 6 decimal places when you just use fixed. Think currency, maybe, where you always want 2 decimal places shown. Fixed helps set that up.
Okay. And then there was show point.
Show point forces the decimal point to be displayed even if the number is whole, like 5.0 instead of just 5. It also ensures trailing zeros are shown up to the set precision. It helps things line up visually sometimes.
Makes sense for alignment. And
Yeah.
controlling the number of decimal places, that was set precision, right?
Yeah. Set precision n, yes, where n is the number of digits you want after the decimal point. This only really works reliably after you've used fixed.
So you use them together, like count fixed set precision to price.
Exactly that. Fixed sets the mode, set precision to specifies 2 decimal places for that mode. Perfect for displaying Harry's average grade neatly.
Nice. And the last one mentioned was set W for width.
Right. SetDov sets the width of the field for the very next item being outputted. It's useful for creating columns.
So if I do count set name, it reserves 10 spaces for the name.
Kind of. It ensures the output for name takes up at least 10 spaces. If name is shorter, it adds padding, usually spaces, to make it 10 wide. If name is longer, it usually just prints the whole thing, potentially messing up your column alignment, but it guarantees a minimum width.
Okay, so set is great for making tables and aligning output. These manipulators seem really powerful for presentation.
They are. They let you transform raw data output into something much more human-readable.
Now, we've talked numbers, characters. What about whole chunks of text? Strings.
Good point. For strings, first, you usually need #include_string.
Got it. String for strings.
Now, if you use sin with a string variable, say string name, sin name, remember how it works.
It skips leading white space and stops at the first white space it finds after the data.
Exactly. So if you type Harry Potter, sin name, we'll only read Harry into the name variable. The Potter part gets left behind in the input stream.
Okay, so sin isn't great if you want to read a whole line with spaces like a full name or a sentence.
Correct. For that specific task, reading an entire line of input, spaces and all, up until the user hits enter, we use a different function, getLine.
GetLine, okay? How does that work?
The common way is getLine, sin, string variable. You tell it where to read from sin and which string variable to store the entire line in.
So if I use getLine sin phrase and type expecto patronum 100 and press enter.
The entire expecto patronum 100 gets stored in the phrase variable. GetLine reads everything up to, but not including, the final new line character from pressing enter.
Ah, perfect for reading user commands, full names, sentences, that kind of stuff.
It's the standard tool for line-based text input.
Okay, fantastic. So keyboard input, screen output, but lots of programs need to deal with files, right? Reading data from files, saving results to files.
Absolutely, especially when you're dealing with larger amounts of data or you need results to persist after the program closes. That's where File I/O comes in.
And for that, another library.
You guessed it, #include fstream, file stream.
Fstream, okay.
This library gives us two main types, classes again, for file operations. Fstream for output file streams.
O for output, like count. Makes sense. For writing to files.
And ifstream for input file streams.
I'm off for input, like sin.
Yeah.
For reading from files.
Exactly. Fstream to write, ifstream to read.
And the videos mentioned a kind of 5-step process for using these.
Yeah, it's a good way to think about it. Step 1, include fstream. We already covered that.
Step 2.
Declare a file stream variable. So if you want to write to a file, you declare fstream my output file or something similar.
Okay, declare the stream object. Step 3.
Associate that object with an actual file on your disk. You do this using the .op member function, like myoutputfile.open results.txt.
Myoutputfile.open results.txt. So now my output file is linked to the file results.txt.
Correct. And an important detail for offstream, if results.txt doesn't exist when you call open, it will usually create the file for you.
Oh, handy. What if it does exist?
By default, opening an existing file with offstream often wipes out the old contents. You can change that behavior, but the default is usually to start fresh.
Good to know. Okay, step 4.
Yeah.
Actually using it.
Yep. Once the file is open, you use your offstream variable just like you use count. Use the insertion operator. So my output file, hello file, writes that text to results.txt, not the screen.
So you just swap count for your offstream variable, and the output goes to the file instead.
Pretty much. Same goes for ifstream and reading. You'd use my input file variable, just like sin variable, but it reads from the file linked to my input file. You can also use getLine, my input file, line, etc.
Cool. And the final step. Step 5.
Crucial one. Close the file. You call the .close function on your stream object, like myoutputfile.close or myinputfile.close.
Why is closing so important?
For output files of stream, closing ensures that all the data you intended to write is actually flushed from memory buffers and physically written to the disk. If your program crashes before closing, you might lose some data. For both input and output, it also releases the file handle back to the operating system, which is just good resource management.
Got it. Open, use, close. Don't forget to close.
Definitely don't forget to close.
So in the Harry example, instead of count average, Harry, they could do outfile.open, harrygrades.txt, outfileaverage, harry outfile.close.
Basically, yes. Assuming outfile was declared as an offstream, the average would end up in the file harrygrades.txt instead of on the screen.
And reading from a file would be similar, using an ifstream and the operator or getLine.
Exactly the same principles apply. File I/O is incredibly powerful for making programs deal with persistent data or large data sets.
Wow, okay. That's quite a journey through C++IO. Let's maybe quickly recap the big points.
Sure. We started with the why programs need to interact. Then the how begins with hashtag include IOStream.
Which gives us sin for input, usually keyboard,
Yeah.
and count for output, usually screen, using the extraction and insertion operators.
Right. And remembering that sin skips white space and reads formatted input, which is often what you want.
But not always, so we have sin.get to read the very next character, white space included.
And sin.nor to discard unwanted input, often used after reading specific items or, crucially, when recovering from errors.
Ah, yes, the failed state. When input doesn't match the expected type, sin breaks, and you need sin.clear to reset it and sin.ignore to throw away the bad stuff.
Crucial recovery pattern. Then for output, hashtag include IOManip gives us manipulators like fixed, show point, set precision, and set to make things look good.
Used with count to control decimal places, alignment, that sort of thing.
Then strings. Remember hashtag include string, and the big difference between sin name, stops at first base, and get line, since on, full name, reads the whole line.
The get line is key for multi-word input.
Definitely. And finally, file IO with hashtag include a stream, giving us upstream output right and if stream in pthread.
Following the 5 steps, include, declare the stream object, open the file, use or getLine and setter with the stream object, and always close the file.
That pretty much covers the fundamentals we explored from Professor Soy's videos. Understanding this stuff is just non-negotiable for writing C++ programs that actually do anything useful in the real world.
It really is the bridge between the program's internal logic and, well, everything else, the user files, data sources. Without it, code is just isolated thoughts.
Yeah, well put. It enables communication.
It makes you think, though. These basic tools, reading characters, writing numbers, handling files, they seem simple, but they're the absolute foundation for, like, everything we see. Web browsers rendering pages, games loading assets, databases storing information.
It all comes down to moving data in and out, fundamentally.
So now that you've got this foundation for getting data in and out using C++in, what kinds of programs does that spark in your imagination? How could you use these simple building blocks to create something interactive or useful? Maybe even think about how this might scale up to things like talking over a network. Lots to consider.
Absolutely. This is just the starting point. There are more advanced techniques, different libraries for specific tasks, but this core understanding of streams, operators, manipulators, and file handling in C++ is the essential first step. Definitely keep exploring from here.